In this video, we're going to be using dimensional analysis to convert a value from megagrams to milligrams. I want to focus your attention to this chart right now. Now you guys, my students who are watching this, you're going to be getting a much more detailed chart with a lot more prefixes for the metric system in it. This is a different chart, but it is set up the exact same way. So the way I've been explaining how to use that chart on the back of the periodic table is going to be the same way I explained how to use this chart right here. The only thing that's different is this chart isn't as detailed as the chart that you're given. But we're going to learn how to use this chart in particular. That way when you do take your test or quiz and you have that chart on your periodic table in front of you, it's going to be the same as what I explained in these videos too, which will hopefully be helpful to you. I do want to cover this chart real quick and explain just the basics of how it works, and then I'll dive into the problem and then we can actually see it being used, which for me personally is the most helpful part. So looking at our prefixes, these values, whenever we're using dimensional analysis, are always going to be equal to 1. So we're looking at 1 megagram, we're looking at 1 kilogram, 1 hectogram, etc., 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 going all the way through. The number that's given to us on the side is the value of how many base units fit into one of these. So what that means is if you have grams, meters, or liters, that is how many grams, meters, or liters fits into one of these. So what that means is, let's look at kilo for a minute, because kilometers, kilograms, and you can also say kilometers, but that's one more that we're more familiar with, and you'll even notice it's in bold on this chart because it's used much more often. So that means 10 to the third meters, so that's 1,000 meters equals 1 kilogram. It goes the same for if you go to the smaller side too. So centimeters is something you guys are all familiar with. 10 to the negative 2 meters is the same thing as 0.01 meters is equal to 1 centimeter. So one of these is equal to this many of the base unit. And we're going to do the example right now and show you how that actually fits into the dimensional analysis problem. I'm going to do my best to color code here. I'm going to get my my setup ready. Some of you guys like to set up the problem first. Sometimes you need 3 fraction bars, sometimes you need 4, and sometimes you only need 2 of these. So don't be afraid to delete or erase. In this case, I'm deleting them on the iPad, but don't be afraid to delete or erase if you draw too many. So I'm going to draw 4. I don't think I need 4, but I'm going to draw it anyways. And when I need to stop, I'll let you know when we know we're supposed to stop and we shouldn't go anymore. So I'm going to convert megagrams right now. I'm going to start that in blue. And I might need to squeeze this in here. 2.00 times 10, oh, that's a multiplication, times 10 to the negative 15. And I'm going to use capital MG, megagrams. And this is a common mistake I saw a lot of in the past week, is whenever you guys were working with megagrams and milligrams, and there was one with a capital P and a lowercase p that's in your other chart, it is so important to make sure you stress the capital and the lowercase. And I chose this example, I made this example on purpose, because in megagrams we use a capital M and milligrams we use a lowercase m. And in chemistry, it is so important that whenever we do have a capital letter, you need to write it as a capital letter. It's very important because, and I'm going to sidetrack here for a moment, you have Mg and you have Mg. That can mean a few different things in chemistry. That could mean magnesium, that's the element on the periodic table, and this can be milligrams, and this can also mean megagrams, and it really depends on the context. But whenever we are working with elements on the periodic table, and if we are working with magnesium and you write it like this with a lowercase, that's not technically correct. That's milligrams. So you need to be very careful. Start making a point to observe whether you have a positive or an uppercase or a lowercase letter, and make sure you stick with that. It's so important. So we're starting with megagrams. I like to put a placeholder of 1 underneath just because it helps me, because we need to have all these fractions here. You don't need to put anything in that placeholder unless you work with 2 units, like miles over hours or meters over seconds. In this case, we're only dealing with 1 unit, which is megagrams, converting to milligrams. So we're not looking at a rate of megagrams per second. So we're going to keep this as a 1 in the bottom. That's all we need. Just one measure of mass to another measure of mass. Since megagrams is on the top of that fraction, I'm going to put it in the bottom of the next fraction. And you guys have overall gotten very good at this. And the reason why we do that is because we're going to treat megagrams up here like a unit that is a variable, and we want to get rid of that variable, and the only way to get rid of it, to cancel it out, is to put it in the bottom of the next fraction, so that technically that cancels out with that, which I'll go through and do that at the very end. I'm not going to cross it out just yet because I don't want to confuse anybody. But what I'm going to do now is I'm going to set everything up. So we have megagrams down here, and I need to convert that to my base unit, grams. So I'm going to do grams in green right now. I just used the wrong tool. Here we go. Green. I think I used a highlighter on accident. So grams is on top. I'm going to put grams on the bottom of the next fraction for the same reason. I'm going to fill in the numbers later, so don't worry about the numbers just yet. So I have megagrams on top, megagrams on the bottom. I can convert from megagrams to grams, so I'm going to put them in the same fraction. When you want to convert from one thing to another, you need to put them in the same fraction. I don't want grams in my final answer. What I want is milligrams. I'm going to do that one in this pinkish color. So I'm going to convert in my final fraction here from grams to milligrams. And I know that's my final fraction because once I get to my value that I'm looking for in my final answer, I don't need to do any more. So I'm actually going to erase that because I don't want to get confused. I don't need that anymore. So here is the whole problem set up without any of the numbers in. We're canceling out our units, so the purples are canceling out, the greens are canceling out, and then we have this one rogue pink milligrams at the end. And that's what we want in our final answer, so that's good. So that's what we're going to end up with. Now, regarding this chart, this lovely chart that everyone loves so much. So all of these symbols, all of these prefixes, anytime you see the prefix, according to this chart, and there are many different charts out there, but this is the type of chart that you will be allowed to use for your final exam, so this is the one we need to get to learn how to use. But according to this chart, when these values equal 1, these values equal our base unit. So I'm going to, every time I see a prefix, so megagrams, I'm going to put a 1, and milligrams, I'm going to put a 1. And I'm using the same color for those for a reason, because these two have the most in common. Also, the grams in green have something in common. We're going to assign a value to them based on the fraction they're in. And that value is going to be in here because we are looking for grams. So I'm going to circle our base unit for this is grams. We're not using meters. We're not using liters. So when I go to megagrams, I see 10 to the 6th power. It's my 10 to the 6th power grams equals 1 megagram. So I'm going to put that all in the same fraction together. So these two values on the top and the bottom are technically equal. 1 megagram equals 10 to the 6th grams. And that's what this chart is telling us. One of these 1 megagram equals 10 to the 6th of our base unit, which is grams. And we're going to see the same thing when we go down to milligrams. So I go down to milligrams, I see 10 to the negative 3. So we have 10 to the negative 3 grams equals 1 milligram. And I hope you can see that's a negative. I just tried to fix that. Didn't do a great job, but it's hard to write on the iPad. So here's my favorite part. You guys know this is my favorite part, canceling out. Boom, 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 boom. My final answer is going to be in megagrams. So I'm going to go ahead and write, milligrams. That's such a common mistake, and I hate it when I do that. So milligrams is going to be in my final answer, and you will be required to write the correct unit in your final answer. So that is how we use the chart. I am going to post at least one more video today on how to use this chart, but I have a total of 3 including this video planned, so hopefully you guys will have some additional examples you can look over as well. I do want to go over how to multiply and solve this. A lot of you guys are getting really good at this. It's basic exponent rules. The problem is it's a lot happening here. There's a lot of numbers and a lot of exponents and a lot of units happening here. So without practice, it can look very, very overwhelming. But with practice, once you get to know how to work it, it's not as bad as a lot of people believe it is. So I'm going to use a different color for my exponents, just so you can get a feel for exactly what I'm working with here. But before I even get to the exponents, something that I want to address, I have the number 2 here. 2.00, that's 3 sig figs, so that means I need 3 sig figs in my final answer. I always look at my original. But every other number is a 10 with an exponent or a 1. So I'm not going to need to multiply this 2 by anything. And the thing that I love about working with metric is whenever I do the unit conversions, I never really need a calculator. A calculator is really great to have to double check your answers. But for these problems, I don't need my calculator for it. Now, whenever we do unit conversions and dimensional analysis, I do strongly suggest you have a calculator, especially for the other problems, just because it will help you. And even if you're really good at the mental math, it's a great tool to just double check your answers. So even when I took the course in high school, I didn't use a calculator often, but when I did, it was to double check my answers, and it helped me so much. Because it's so easy to make mistakes if you're working everything out in your head. So now I put my 2 in my final answer, my 2 times 10, and now I got to figure out with these exponents what to do. We've gone over before, when we multiply, we're adding our exponents, and when we divide, we subtract our exponents. So something that I have found helpful after working with you guys and using all the highlighters and color coding is I like to use a different color to circle or underline my exponents, and then go off to the side and just kind of write out exactly what I'm calculating. So I'm going to write in parentheses negative, that's supposed to be a negative, 15 plus 6, and I am going to subtract a negative 3. And if it helps you to put parentheses around that, you can. And forgive my sloppy handwriting here. So I have negative 15 plus 6. Negative 15 plus 6 gives me negative 9. And when you subtract a negative 3, it's the same thing as adding 3. So negative 9 plus 3 gives me negative 6. So that should be my new exponent. And here is our final answer. I'm going to post this right away, and after it's done posting, I'm going to work on the next video. So they will slowly be coming out throughout the day today. I'm planning on 3 videos currently. If there's a particular example you would like to see, send me a message on Schoology, let me know, and I'll be more than happy to make a video on it.